Live from the Washington, D.C. area, it's the Inside Scoop, Emerald Planet. All the ecology news that our viewers want to know. Now, here's your host, Executive Director of the Emerald Planet, Dr. Sam Lee Hancock.
Hello and welcome to the Emerald Planet as we come to you from Washington, D.C. in the United States as we look around the globe in 144 different nations, looking for the 1,000 best practices, the technologies, the services, and the products that are making a difference as we move through the 21st century. And as you know, we're adding about 2 billion new people to the planet by 2050. So with 9 billion people to feed, house, clothe, and provide the basic infrastructure, how are we going to be able to take care of all those people and not just allow them to exist, but to actually have a higher quality of life? And of course, one of those higher quality of life certainly entails water and everything that centers around that, and the ecology of the earth, as well as the nutrients that come from both fresh and saltwater areas. We have someone who's sitting right beside me who has a very exciting and interesting program in the Washington, D.C. area. It's Dr. Kim de Messert, who is Assistant Professor at the Department of Environmental Science at George Mason University. And Kim, welcome to the Emerald Planet.
Thank you. Glad to be here.
Glad to have you with us. Tell us a little bit about the department and also the Potomac Environmental Research Education Center. It's a very long name,
right?
And it sounds like it's doing very good things. Tell us about it.
Well, thank you. Yeah, it is a very long name, so we like to abbreviate it with PERIC. And it's an environmental research center really dedicated to study the Potomac River. We're mostly interested in effects of anthropogenic stressors on the river. We're interested in projects that concern sustainability, restoration, natural science. And I guess some exciting new news is that we're creating a new center on the Occoquan River that is right on the river, which really helps us with our science. We can have wet labs there that can use the water from the Potomac, and really helps us with our mission at George Mason.
Well, looking at the Potomac River, this is very famous because that's where Washington, D.C., of course, is located, and much of the English history of the United States over 400 years has occurred around this river. So looking at it, what changes has the river gone through over these centuries? And now it's like it's almost reversing back to its natural state of what it was even 400 years ago. And I think isn't that part of your research?
Yeah, there was, after DC was built, there were a lot of problems with the water quality. And all the way up to the 1960s and 70s, there were massive cyanobacteria blooms, poor water quality in the Potomac River. And studies indicated that the high loading of nutrients, specifically nitrogen and phosphorus, were to blame for that. And basically proactively, Fairfax County and a wastewater treatment plant that I'm studying, is one of the ecological studies I'm involved with, removed those nutrients from their effluent. And that's when things really started to change for the better, actually.
Mm-hmm. Well, I want to go to this. I think this is absolutely fantastic, this new facility that you're building at George Mason University. Tell us a little bit about this and its position and just the importance of having this kind of new facility for your research.
Right. Well, I'm very excited about this building. It's a 50,000 square foot research facility overlooking the Occoquan River. It has room for, right now we're starting with 7 PIs, so principal investigators that have their offices, their labs, students, postdoc staff can locate over there, and it has room for local meetings of perhaps community groups. We have a discovery lab for K to 12 students visiting classes of those, and a display gallery that's open to the public. So with that facility, I think it will become much more visible what the research is that George Mason is doing on the Potomac River, and also really increases the access for us to the river with boats there and a dock there.
Well, we're staying on this picture because I think it really says, you know, 1,000 words about, you know, what you're doing as far as George Mason University is concerned. But looking at the quality of this, and you're actually right overlooking the river.
Right.
I mean, it's just an absolute pristine location there, and this is really a dynamic area to attract students from, and I would assume you're going to attract from all over around the globe, correct?
Yeah, I certainly plan to do so.
Mm-hmm. Now, looking at PERIC, this is the Potomac Environmental Research Education Center, that very long name again. But what attracted you to be a part of what's going on there?
Well, what I really like about it is that it's a multidisciplinary team of scientists. So we have a geologist, environmental chemists, sustainability experts, natural scientists that are focused on water quality. Me, I'm mostly focused on fish ecology, fishery science. And with that, it really allows us to work on a problem from different angles, so that if we look at how the effluent of a wastewater treatment plant affects the river, we can look at how it changes the water quality, how it changes the fish communities, what chemicals can be found in the fish that are present in the effluent. And with all of us being there, we can very quickly come up with proposals for studies like that and work on those problems.
Well, we're looking at a very detailed map, and there's a lot of legend in all of this. Tell us about the Gunston Cove study, and what are you seeing as far as the impact and the benefits from having such a complex study?
Right. So you're indeed looking at Gunston Cove and some of our research sites. So this was started in 1984, and
so this has been going on quite a while then.
This has been going on quite a while, and actually Chris Jones, who is the director of the PERIC Center, was present at the beginning of this study, and I obviously jumped in later. But what it was tracking at first was really the water quality. After the nutrients were removed from the Nomenham Coal treatment plant, we did not see a response from the system. So the ecological study was really formed to see what was going on. And what Chris discovered was there's this what's called a phosphorus memory. So the sediment took up so much phosphorus that even if you clean it out of the effluent, the phosphorus that is stored in the sediment is released and really delays a response.
And that's gradually released over time. So even if you're not stirring the bottom, it's still going to be released into the water.
It seeps out. So you really need a long-term study to see this change. Eventually, we really saw a change from the better. Basically, a state shift from a phytoplankton-dominated system to a system with submerged aquatic plants, clearer water, that also caused a shift in the animal communities, the fish, the benthic invertebrates, and so on that we see there. But that really only started occurring, that clearing up of the water, in 2005. So you can imagine how long it took for that phosphorus to really be removed from the sediment.
So that's 1984 to 2005.
Right,
that is
right.
a long time period. And I think if we look at the impact of climate change and, you know, whether humans are doing that or not, you know, this somewhat of a debate that's going on is that whatever we're doing to the environment is a long-term impact. And we have to be aware of that.
Exactly, and I think it has been pretty well established that climate change is caused by human action.
Right. I think 95% of all scientists that are seriously studying this are saying that it's definitely true.
Exactly.
How have the fish responded as far as this change in the ecosystem of the cove and also the whole Potomac River?
Well, it was an interesting change because it's a complex problem. Phytoplankton also fuels the food web. So phytoplankton could actually increase the amount of fish that you see there. So we didn't see a change in the amount of fish that were there, but we saw a change in the community composition. So fish that were more associated with plants, we saw them coming into the cove. Visual predators, a lot of the fish people like to fish for recreationally are visual predators like largemouth bass, striped bass, and they are now more represented in the community. So those shifts in the community very much follow the changes in SAV growth. So the image that we're looking at right now is the SAV expansion that was seen in 2005. That was really right after that shift. Before that, water clarity was just not high enough to reach the bottom and plants couldn't grow. At that moment when water clarity was increased, really that shift occurred from phytoplankton to SAV, and the fish community changed with that. So you see different fish, and most of those are fish we like to see in the system.
So what we're doing is just like we're going back to native plants on land and trying to restore the trees and the shrubs and the underbrush, throughout the areas to adjust to climate change and also to bring back the traditional environment that we have. So this is really happening in the water as well then.
Right, exactly. And climate change, of course, is also a problem in the water as well.
Now this is something that's very complex. Tell us what is going on in this area, and I know this is all about fish.
Right, so with this image I just want to quickly show the shifts in community that you see with the expansion of SAV cover. So SAV is submerged aquatic vegetation. When there was no cover, when the dots on this graph are grouped together, it means that those community samples there are very similar. So you really see 3 distinct groups in there, and those groups are based on what the SAV cover was. So it's very interesting how the fish followed the extent of that cover so precisely that you see those distinct groups.
Well, this is really a beautiful area where you're working, Kim, and it's absolutely fantastic, and there's only about 30 seconds left, so we have to be quick. What do you see for the long-term improvement as far as the Potomac, then to Chesapeake Bay, and then the Atlantic Ocean?
I think we have to be very wary of non-point source solutions. So basically, whether there's pollution in stormwater runoff. I think at this point, that plus climate change are the biggest problems, Steve, that we need to tackle.
So we got to take them head on in order to restore the environment. Dr. Kim de Messert, who is the Associate Professor, Department of Environmental Science, George Mason University. Thank you. And thank you for watching as we create the Emerald Planet.
Art, a universal language, an expression of culture, of self. And now, thanks to Empowered Women International, a way for emerging and established immigrant and refugee artists and artisans to find hope to earn a living while enriching the lives of all of us. Empowered Women International, making a better America every day. For more information on Empowered Women International's educational programs or to make a tax-free donation, contact cfripp at AOL.com.
Here, kitty, kitty. Here, kitty, kitty, kitty. Here, kitty, kitty.
You'd think it would be easy to tell which kids have trouble with their eyesight. But that's not always the case. Even though 1 in 4 children may have a vision problem, eye doctors tell us the symptoms aren't always so obvious. We do know that 80% of all childhood learning is visual. And without good vision, kids can have trouble learning to read and may fall behind in school. For clues on how to spot the real-life signs of childhood vision problems and what parents can do, visit checkyearly.com. A public service message from the Vision Council of America and Reading is Fundamental.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Hello and welcome to the Emerald Planet as we come to you from Washington, D.C. in the United States as we look around the globe seeking the 1,000 best practices, the technologies, the services, and the products that are making a difference as we move through the 21st century. And of course, as we move towards 9 billion people on the planet, how are we going to be able to provide the water, the food, the fuel, the fiber, the basic infrastructure that's needed for all these human beings? We have two gentlemen that are joining us from George Mason University. They're looking into the cycle of life centered around both fresh and salt water and how that we can make a difference in the planet as we move forward to 2050. Right beside me is Dr. Gregory, goes by Greg Foster, who is the professor, Department of Chemistry and Biochemistry. And I'm sure there are many students that come to you fear and trembling with chemistry and biochemistry. And then Dr. Thomas Tom B. Huff, who is a director of what's called the Shared Research Instrumentation Facility. So I'm going to ask you lots of questions about that. And this is the Potomac Environmental Research and Education Center at George Mason University. And Tom, I'm going to start off with you because you absolutely have the longest title of affiliation of anybody that's going to be with us in this program. Tell us a little bit about that. What is the Shared Research Instrumentation Facility?
It's a combined facility where each department can sort of pool their resources together and have a laboratory that has high-level equipment for doing chemical analysis and some biochemical analysis as well. And the idea is that it provides a place where instruments that are very expensive and difficult to operate can be set together and cared for and kept available to the students and to the faculty who use them. And that helps each of the department sort of avoid the high cost of each department needing their own instrument.
Now looking at that, I know you would have a number of graduate assistants that would be involved in all this, and I'm sure you have technicians that are maintaining the equipment, and I'm going to just follow on, Tom, with that question. So looking at this, you have something that's shared across all faculty. How do the faculty schedule and become involved in this? And then how does the community and people that say would like to provide grants know about the equipment and the research that you're actually doing at the university?
Right. Well, we have a rather informal scheduling period. It's done mainly through contact directly with the researchers. It turns out that not every research project requires the same amount of work with an instrument. So some instruments will be used exclusively and for an extended period of time, where some researchers just use the instrument as a small part of their overall project.
I see.
So depending on what the needs are. Generally, I talk to the people, try to find out what their goals are and what they need and what they're trying to accomplish. And then I can work with them to schedule a good period of time so that they can get the work done.
Well, Greg, you're sitting here and your title is Professor, Department of Chemistry and Biochemistry, but I know that you've been in administration for a number of years. And this Potomac Environmental Research Education Center has come about under your watch. And tell us a little bit about that, and then what is some of the outcomes that are being achieved through having such a high-ranked center?
Yeah, it's one of the, we have 20 centers in the College of Science at George Mason, and the PERIC is one of the large centers that we have. I was first a member of PERIC, then I became an administrator, and it's been fun to see it kind of grow and develop as my time as an administration in the College of Science. And it plays a very important role in education, K through 12 education, and we have outreach, so we can reach the community and kind of inform them as the things that we're doing, what's happening in the Potomac River. And so it's been kind of very exciting and fun to be part of that kind of development. The conservation and aquatic ecology and biodiversity are real kind of thrust areas in the college, in fact, at the university. So PERIC is right dead center in that area, and we're very excited about that.
Well, that's fantastic. And looking at this, and this is a follow-on question about this, it looks like you're really reaching out, and this has almost become a community resource as well as just for the students, the research,
right,
and what the faculty is doing.
Well, when you work in the environment, you know, education, of course, is a primary driver along with research, but you have to have outreach. You have to have a connection with the community to let them know what they're doing, because we want to involve them, but they're the ones that are affected too by air quality and water quality and whatnot. So we really depend on their input, their interest, and their support. So it's important that we play a very large role in outreach, and we like to kind of make contact with the community. It's important to us.
Oh, that's fantastic. And Tom, you know, we were talking about the river and the resources it has. It's very important for the economic viability of the Washington, D.C. capital region, all the way down to the Chesapeake Bay and out even into the Atlantic Ocean. And we're all about best practices. But we have to talk about some of the contaminants that have been there, that's been accumulating over some 400 years of economic and social development along the river. So what are some of the contaminants that are there, and then what is happening through the center to identify but then find ways to remediate that?
Well, the contaminant list is growing as we speak.
So it's not becoming less?
It's not becoming less by any means. There are tens of thousands or more contaminants that could possibly be discharged into surface water, such as the lakes, ponds, streams, rivers, estuaries, and so forth. And they come from a great deal of sources. Some of the biggest ones are historical, because they were put in large quantities long ago, but still get locked into the sediment and are still there present. DDT, for example, was banned in, I think, 1972, yet we can still measure it and we see traces of it. It's used in some places as well, but these are sort of hereditary types of contaminants. The ones that we work with specifically are toxins such as PAHs, which are priority pollutants with the Environmental Protection Agency, and also toxins like PCBs, which were also kind of a legacy pollutant because they were used extensively in the electric industry. They were materials put into transformers and now have leaked out or been discharged into the water. And one of our big interests, and the PERIC will be situated in a place where we can really look at this, are the herbicides and pesticides that are used extensively throughout the agricultural area in the watershed that leads into the Potomac.
Yeah, well, and also too, I think there's a lot of leaching from, say, golf courses, and
Yes.
and a lot of the ornamentals that people have in their own yards that are getting in, and contaminating the river.
We see agricultural sources, we see urban sources, and we see suburban sources. A lot of the areas that we look at are primarily residential, so we'll look for the typical lawn chemicals that people do tend to overuse, and they end up in the waterway through runoff through the streets, as well as agricultural.
I see. Greg, why should the general public be interested in the research that's going on, and also some of the ways that you're learning through the centers that you have there at George Mason University, that you can actually try to back and remediate for some of that contamination.
I think some of the big interest that the community has is the Potomac River is a valuable resource. It is the second largest flowing river in Chesapeake Bay, so it's a major river. It's something that's close to all of us. We have access to the river, we can identify with it. And more importantly also that it's a drinking water source. So we pull our drinking water from the river, so I think we're somewhat concerned about water quality in the Potomac River.
Right.
We harvest food products from the river, we fish and whatnot, we swim in the river. So I think all of those recreational kinds of activities kind of make the river very important to us. And we just, by and large, want to keep it healthy and clean.
Tom, what are some of the field studies that you're conducting using the joint facility as well as the center itself?
Well, what I've been looking at closely are what are called transformation products. Those are products that originated as, for example, atrazine, an herbicide that's used in over 73% of the cornfields in Virginia. And once it gets into the environment, it starts to interact with the water, the sunlight, and the microorganisms along the way. And they make changes, albeit small changes, to the molecules, and they are transformed into other products that we still don't know what their effects are on the ecosystem. So we're looking at sampling seasonally, where we can see the application period for atrazine in the early spring, right before crops are planted. They knock the weeds down, and there's a large concentration buildup, and then the bugs, the sunlight, the water all attack it, and we watch at what the profiles look like through the course of a year. So we'll go out and sample monthly or bi-monthly, and then look at what the changes are over time.
Greg, looking at your research in environmental chemistry, and I know that biochemistry is actually in your title that you have there, how does all this blend together, and then what are some of the things that you're doing to actually research? And we're running out of time, so we have to be quick.
Okay.
And then again, the impact on the public.
Yes, well, I think that part of my interest is, as an environmental chemist, look at fate and transport of chemicals, sources, how chemicals get in, where they come from, how they kind of translocate through the system, but also toxicology is how they affect the fish community and whatnot. And just the health of the fishery itself, and then the public health concern of the fish having contaminants that people might consume and be exposed to, and that's kind of a big picture, big important thing to look at too. So I have an interest in all of that. I think we're looking at kind of, as you mentioned, best practices, how we really deal with how we live in our lifestyles and what impact that has on water quality, because we are connected. Some really interesting chemicals that we're working on now are kind of drugs and their derivatives that come in through wastewater. People maybe not associate that as an important source, but it is a very important source. So there you go, that we're all connected to the river.
Well, Dr. Greg Foster, thank you for being with us, and Dr. Thomas B. Huff. Tom, thank you for talking about your shared research and station facility as we create the Emerald Planet.
One day these rats were playing in the woods. Well, it's some matches and that's no good. Listen to smoke before you give it a try. Only you. Don't play with matches. Don't play with fire. Cause there's nothing very funny about nothing very nice on a homeless mind. So if a gorgeous force is what you desire, don't play with matches. Don't play with fire.
Only you can prevent wildfires.
Fire.
Why don't you just wash your car at home? When I wash my car, everything runs down the street and down into the storm drains. With all the chemicals in the soaps and waxes, the last thing I want to do is poison my own drinking water. At least here, it's all contained and recycled on site. That's why I also take my car in for oil changes instead of doing it myself. I might take a chance on spilling stuff. You know what the best part is?
What?
More time to kick back and watch the game.
How far would you go to protect the planet?
I want you to build an ark.
Here we go. ask. Oh, okay. Ow!
Maybe there's another way.
People, the flood is imminent!
Is it too much to ask for a little precipitation?
Go to fightglobalwarming.com to find out what you and your community can do to reduce global warming pollution.
Somewhere around the world, there are men and women of the armed forces risking their lives, helping rebuild communities after natural disasters, collecting toys for needy children, tutoring kids in school. These are your sons and daughters who work to keep us safe, secure, and free. Dedicated men and women who put their country first.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Hello and welcome to the Emerald Planet as we come to you looking in 144 different nations, looking for the 1,000 best practices that are going to make a difference as we move towards 2050. And we're looking at the way that we're going to provide the sustenance and the basic infrastructure for 9 billion souls by 2050. And perhaps there could be as many as 12 billion people on the planet by the end of the start of the 22nd century. And so how are we going to take care of all that? And we have a gentleman that's going to be talking about sustainability, and really it's not just the research of sustainability, but also about the civil society development and the psychological constructs of that. And his name is Dr. Daniel Dan M. Scudero, who is the Associate Professor, Applied Ecology and Sustainability at George Mason University. And Dan, welcome.
Thank you, Sam.
Glad to have you with us. Tell us a little bit about this field of what's called applied ecology and sustainability.
Sure. Well, ecology is all about how the world works, how the natural part of the world works, and so to support life. And so when we talk about applied ecology, it's how can we use this knowledge to help us to be supported?
Well, looking at the chart that we have, this almost looks like Maslow's hierarchy of needs, and maybe that's what we are looking at, Dan. So tell us a little bit about this, but extrapolate that out to how we're looking at sustainability as we're moving through the 21st century.
Thank you. Well, as you know, a lot of people have heard that sustainability is all about meeting the needs of the present generation without sacrificing the needs of future generations. So from my perspective, you need to start by thinking about those needs. And we have both body needs, things like food, water, air, security, and things like that. And then we also have mind needs. How can you be creative? How can you be self-respected and things like that? So it is a hierarchy in Maslow's sense 50 or 60 years ago. But today we recognize that if you don't have all of those needs, you're not necessarily going to feel like you're a sustained, thriving person.
Well, this whole thing, Dan, as we look around the globe and this kind of the tug and pull between developed nations and developing countries, what now called emerging markets, and they're saying, look, you guys have been there for the last 150, 200 years. We're just getting there. We want ours now. We don't want to wait. So I think this pyramid that you have here, is this something about, hey, let's do it now, not wait?
Yeah, that's right. And actually, not just about not waiting. We have to do it everywhere for everyone. So it's not about simply how do I meet my basic needs, but we found through a lot of psychological research that people actually feel happier when their other people's needs are met as well. So we can think about sustainability really trying to bring together not just how do I take care of my needs, but how do we all take care of our needs. And key to that is really thinking about the things that we need, the enabling processes, the people, the planet, and the prosperity, as we say, the 3 Ps of sustainability. And when we're talking about people, really thinking about, how does everyone's needs can they be met collectively and individually? And then, also how can we live in harmony with the planet, which is all those life support systems we might talk about before. And finally, the prosperity, not just material wealth and having enough money in your pocket, but also how do we build up the living wealth, the infrastructure of nature to really support us now and hopefully forever.
Now, looking at, and this is what we're looking at right here, and this is this people, planet, prosperity. When did this evolve and moving into this living sustainability, which is really the new catchphrase as far as where we're going to, as far as meeting the socio-economic and the civil society needs of the whole planet? And that's a very ambitious goal, Dan, because you're trying to do it all simultaneously.
It is. It's very ambitious. You know, in way back in 1992 in the Rio Earth Summit, they really tried to play out the idea that you know, we're going to meet the present and future's needs, but we didn't even have present needs met then. And in fact, in the subsequent years, we put together this whole idea of having a set of Millennium Development Goals that we would try to reach by 2015 to make the world a little bit more sustainable than it was 20 years before. And we've had some success in that regard. We actually have the proportion of people who did not have access to clean water, for example. And that's a really, really stupendous accomplishment. I'm really happy to know that as a water guy. And on the flip side, there are a lot of misses we've had. For example, in 1992, we had 1/4 of the world did not have access to enough nutrition. They were undernourished. And today, now it's just 1 in 6, which still sounds like it sounds like an improvement, but really, I wouldn't want to be that 6th person at the table without any food to eat. So really, we're going to have to work through not just the social and civil aspects, but also the environmental aspects and the ecological aspects that we need to be able to meet our needs now and in the future.
Well, this whole thing about being on planet Earth as we rotate through the universe, I mean, we really do have to be this balance of the environment as well as economy and civil society. Looking at this map, I know this really goes to the heart of what you were just talking about. What are we looking at here? And between the very dark emerald green to the bright red areas, what is the problem and what is the challenge we have to meet over the next 50 years?
Thanks for asking. Well, one of the things you see really clearly is that the green areas represent places where we're on progress to meet these Millennium Development Goals. So in places like China, Central America, places in South America like Brazil, we see countries that have really made a strong effort over the last 20 years to really meet the sorts of needs that their human populations need in order to thrive. On the flip side, there are other parts of the world, particularly notably Africa, where these countries have actually, in some cases, taken a step backwards. And it's not necessarily strictly due to forces inside. The decisions that we're making here in the United States and in other countries impact those countries and can result in embedded losses and embodied losses in their energy and their natural resources that put them at a disadvantage compared to other places in the world.
Yeah, looking at these red areas too, we talk about these high conflict, and of course we know in the continent of Africa there's supposed about 38 low-level to high-level conflicts going on simultaneously, and then when you have internally displaced peoples, that's a real challenge as far as health, nutrition, education. So looking at these areas in the bright red, we see some that actually moving into the Middle East and up into the European area. So what do we need to do to look at this whole thing about this balance of people, planet, prosperity?
Well, I'd like to focus particularly on the planet side, because what we found right now in the international negotiations about the Sustainable Development Goals, what goals will we have after 2015? For the most part, the environmental aspect is being overlooked. And so as we saw before in those 3 circles, we're thinking about people, we're thinking about prosperity, but we're kind of forgotten about the environment. And so one thing that Africa is really well known for is having amazing natural resources, beautiful places. Most of the animals we learn about in childhood, have come from Africa or we see in Africa. And here we have, people and prosperity met, but we've kind of put aside the planet part, and that's going to be a real challenge for the future, particularly as we take more and more out as our population, as you've mentioned, goes from 7 to 9 or even a larger billion number of people.
Yeah, I tell you, it's just incredible when you think about 12 billion people by the end of this century. What are we looking at here? This looks like a complex spider web, and I know this is something a construct that you've been working on for some time and showing how we're going to hopefully meet some of the challenges of the future.
Yeah, well, I won't take credit for the construct itself, but I definitely relate to the values here. Essentially, it's showing the Earth in the center, and if we, along these 9 different axes of critical areas, natural areas to support human life in our society, if they're met, they're inside of that little green part of it, and if they're not met, they're stretching out into that red part, either a little bit or a lot. And what you can see right now is that climate change, the nitrogen cycle, and the rate of our biodiversity loss are all going to pot. They're really much beyond what we think can be sustainable in the long term. So So it's our lifestyle actions that are affecting that. So in climate change, it has to do with how we're using energy and the byproducts of that being carbon dioxide. In terms of the nitrogen cycle, we're producing artificial fertilizer, and a lot of that we're letting waste and go straight down into our waterways and pollute them. And on biodiversity loss, it can be in terms of introducing species that shouldn't be there, over-harvesting the species that are there, or changing land use in such a way that the species that we might depend on in the future medicines, et cetera, won't be there in the future.
Well, looking at the complexity of all this, and this is one of the things, Dan, that we don't really think about, is like, let's see what we can use today and not in the past so much worry about in the future. Now we really have to look at the future and the whole product cycle. The future is what we need to focus on, and then we back in how can we actually use that today. I think that's what you're talking about.
Yeah, absolutely. And being a professor of sustainability, I get to talk to my students as being the future, and I say, before you die, it will be 2050 hopefully, and then 2200 as well, and they can live these lives, these experiences. And so we can think about how each of them have contributed to the global impact on our environment using a tool called the ecological footprint. Now, I don't say this is the be-all and end-all of measuring your impact in the world, but in one way it can allow us to say, if everybody lived like me, what would it mean for the whole planet? And even though we've recently found 8.8 billion other Earths out there, or things like that in the galaxy, this is the one we live on. And so we've seen over the last 50 years, we've gone to being pretty much living within the ecological limits of the planet to being about 50% over what we think is going to work over the long term. And if that continues, by the middle of the century, we'll be somewhere around three Earths in our capacity.
Yeah, I think
unless
this
we do something different. Yeah.
Yeah, I've seen this before, and I find this really fascinating. Is that how many Earths we're actually consuming as human beings of about 7 billion folks, and then by 2050 we're going to add another 2 billion people. And then think that we're going to have about 12. So, it's kind of hard to get your mind around that we need 3 complete Earths in order to take care of all the humankind that we're actually producing and going to have on this planet.
Yeah, just thinking about food, there's some estimates we'll need 70% more food in the mid-century in order to feed all the mouths. That's quite a lot of burgers if you want.
Well, looking at the challenges that we have, we're looking at the United States here. What is the intersect? And these lines are going where?
Well, unfortunately, the ecological footprint line per capita in the United States is going up or rising gradually, and the per capita bio capacity is going down, which is to say the amount we can get out of the land per person, whether it's water or the amount of food we can produce, it's going down because our people are going up. And unless we can bring those more into alignment, the United States is going to have to bring more and more of its natural resources from other countries to fulfill our needs here in this country. And that's being replicated, in fact, all over the world in many different places.
Yeah, I think this is looking at this students' ecological footprints. We're running out of time. This is a fascinating topic. So what are we looking at here, and how are we going to get the students of the future actually involved right now?
Well, the take-home message here is that across about a half a dozen countries of students that I've taught over the last couple of years, only one sole Indian was living a lifestyle that was self-assessed as being within our ecological capacity of the planet. So students really need to take the lead. They are the leaders of the generation, doing important things like assessing what are the issues that they're dealing with that are sustainability hazards in their own lifestyles, and then planning what sort of activities they can do to address those in the future.
So looking at that, and we're absolutely flat out of time, so we don't have a chance to get on over this, but what do you see for the next 20, 30, 40 years? And we've got about 20 seconds to say all that.
That's fine, I'll say it. I think we need to focus on efficiency, conservation, substituting bad things for good things, upcycling things from trash to resources, and transforming our lifestyles in a way that will really help us to build a more sustainable planet.
And I like that. You're transforming, but also collaboration among all human beings and countries, universities, and all institutions around the globe. Dan, thank you for being with us and sharing about all this. And thank you for watching as we create the Emerald Planet.
Saving for retirement might be easy for some folk, but for others, it might take a little more work. And for those who haven't started, there are still things you can do to catch up.
Oh, that is good news.
Like getting out from underneath past debt. And don't get wrapped up with high-interest credit cards.
Get you some eyes.
Be diversified with your investments. Don't put all your eggs in one basket. Your financial goals are not out of reach. The choice is clear. For a happy ending, choose to save.
Everyone with alcohol and drug addiction is in the same boat. With treatment, you can find solid ground. For drug and alcohol information and treatment referral for you or someone you know, call 1-800-662-HELP.
Dude, are you sure you want this tattoo? Because just do it.
Some mistakes in life are permanent. Like hearing loss. To learn how to protect your hearing, visit ASHA.org.
You've probably heard about heart disease, but did you know that it's the #1 killer of women nationwide? Heart disease claims more lives each year than breast cancer, lung cancer, or strokes combined. But there are steps you can take to protect yourself against it. For more information on how you can prevent heart disease, contact your local American Heart Association or visit their website at www.americanheart.org.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Well, I'm Dr. Sam Hancock, the President and Executive Director of the Emerald Planet and Emerald Planet TV, headquartered in Washington, D.C. in the United States. And we come to you once a week broadcasting about the very best practices, the 1,000 as we talk about, as far as the technologies, the services, and the products in over 144 different nations. And we're looking at that as far as what are the solutions. Many people know the problems that we have as we're getting ready to add 2 billion new people to the planet, so possibly 9 billion by 2050, and then we're moving towards maybe even 12 billion people, possibly more, by the end of the century. So how are we going to provide the food, the fuel, the fiber, and also to have the quality of the air, the soil, and the water that we need to take care of all these new people? I have a gentleman who has actually been studying and working on this for a long time, Dr. Randy A. McBride. He is Associate Professor at the Department of Atmospheric, Oceanographic, and Earth Sciences at George Mason University. And I told Randy that we're going to dwell a little bit on just the topic as far as his department is concerned. Tell us this combination, atmospheric, oceanographic, and earth sciences.
Well, thank you, Sam. Our department has about 20 faculty in it, and we're made up of oceanographers and atmospheric scientists and geologists, and we study the physical aspects of the atmosphere, the ocean, and the geologic deposits. So things such as predicting climate change and understanding El Nino, as well as looking at different geologic phenomena.
Well, looking at this balance, and I'm going not just within the title that you have here, but the earth, the air, and the water. Many people, they focus on the water, and we say, well, we need to take care of the land, then we need to have the air, but actually all three of these are intertwined, and if you're taking care of the water, you're in essence taking care of the other two. And so how do we really bring these together so that we really have a comprehensive view of how we're going to balance taking care of the air, the soil, and the water, and at the same time, how is that going to aid us as we move towards 2050 with 2 billion more people on the planet?
Yeah, and that's what our department does. My colleagues and I study different aspects to understand what's going on in the atmosphere, in the oceans, and geologically, so that we can help understand what happened in the past, and so that we can help predict what's going to happen in the future. So to me, that's pretty much the most important thing that we can do as scientists, especially the physical scientists.
Mm-hmm. What is some of your primary research that you're involved in?
Well, I'm a coastal geologist, and I study coastal depositional systems along the U.S. Atlantic coast and Gulf coasts. And I specifically study things such as barrier islands and deltas and estuaries and continental shelves. And my graduate students and I look at storm impacts along Assateague Island, National Seashore, shoreline changes of like Paramore Island and Cedar Island, and look at the geologic framework of Cedar Island using short cores.
Now, looking at these two photographs here, we're using these purposely so we can take all these words and convey this to both our domestic and our international audiences. What are we really looking at here, and what is the importance of what we're looking at as far as humankind and at the same time having this balance between the air, the water, and the soil?
Yeah, well, most people are familiar with Virginia Beach because there's a lot of tourists there and so forth, but most of Virginia's shoreline, the outer shoreline, is dominated by barrier islands. And what you're looking at here are two slides or two images showing how much the shoreline is eroding. And so you have these salt marsh deposits outcropping out on the beach, which is atypical, meaning that the beach is moving landward and the shoreline therefore is eroding.
So what is controlling this? These barrier islands, you're saying that many of them are eroding away, they're actually just disappearing, well, and there's less opportunity for the storm surges to break away from the mainland, if you will. So what's happening in all this?
Yeah, really what controls our shoreline and the shoreline movement is really three major factors, three primary factors. One would be sediment supply, how much sediment is reaching the shoreline or the lack thereof. The relative sea level, is the sea level rising or falling? And right now, of course, we have a global rise in sea level. And thirdly would be the impacts of storms, such as hurricanes and northeasters.
So you're talking about the Gulf, which is the Gulf of Mexico and the southern part of the United States, and then the eastern shore of the United States. What similarities or what differences are we seeing between what is happening in the Gulf and what we're happening along the Atlantic seacoast?
Well, in a lot of ways, there's a lot of similarities. Both shorelines are predominantly eroding. Louisiana, for example, has the highest rates of erosion in the United States, but guess what? Virginia, for all the states along the east coast of the United States, has the highest rates of coastal erosion along the east coast, and we have rates approaching 15 meters per year of erosion horizontally in a landward direction.
So looking at that, how do we translate that, Randy, as far as the future, as far as sea level rise and also protecting very valuable assets? Because, you know, we have the largest naval seaport in the world in Norfolk, you know, along those 5 cities in Hampton Roads area. And then, of course, there's huge assets up and down the East Coast and the Gulf. So how does that directly, practically relate to the economy and the environment that we have within the United States in studies that may be helpful across the globe?
Mm-hmm. Yeah, well, these assets are definitely vulnerable. And what I'm seeing in my research is that shoreline erosion rates are accelerating. And if you look at the long-term rates, they're averaging about 5 meters per year, but more recently, over the past 10 years, they've been accelerating and approaching rates of 15 meters per year. So that means that we have to better protect assets along our coast and do practical measures that help protect those assets by providing more sediment to the shoreline and so forth.
This looks like a very simple apparatus, but I know this is quite profound as far as the research and testing that you're doing, Randy. Tell us what we're looking at here and why should we even care?
Well, that is a sediment coring device, and what, as a coastal geologist, we have to take cores into the subsurface to better understand what's happening below the surface. And it really tells us how the barrier island is migrating landward and what deposits have been preserved, especially tidal inlets that have been breached through the island in response to those storms and storm surges. So we're able then to look underneath the island. And here's an example where you have an inlet that was breached in the late 1990s, and they tend to open, migrate laterally, and then close. And then what I do with my research is we go and drill those inlets after they've been closed. You can actually then document what we call tidal inlet deposits, and you can actually show then what was happening with that inlet when it was open.
Mm-hmm. So looking at this photograph that we have here, of course, this is a satellite, and we see this breach that you're talking about here, and then this is, you're looking at the sediment and you're trying to do the core analysis. What is that actually telling us? What do we know from this as far as the future is concerned, as far as future storm surges, sea level rise, where we actually should be involving in economic activity and maybe retreating back from the seacoast in order to protect our assets?
Mm-hmm. Yeah, well, the deposits show us that it tells us all about the dynamics of the inlet when it was open, how much water was flowing through the inlet, what the deposits, what kind of deposits were being laid down, and so forth, and how the inlet has changed through time. And what we're seeing is that the volume of water through past inlets and present day inlets have been increasing in response to sea level rise.
And looking at what is the amount of sea level rise, Randy, that we're seeing around the globe and the eastern and also the Gulf of Mexico for the United States?
Well, globally it's averaging about 2 to 2.5 millimeters per year.
Which is how much in as far as the old English system? I know you're doing.
You caught me off guard.
The metric.
I operate in metric as a scientist, and I'd need to get my calculator out and figure it out exactly, but it would be inches, less than an inch per year.
But still, that's significant.
Yes.
Because over a number of years, all of a sudden we're 12 inches, that's a foot. And then that's a third of a meter. And so now we're actually talking about real numbers. So how do we go about addressing this? What kind of best practices are being used, say, in the Gulf, along the Atlantic seaboard, that are actually maybe trying to reverse this trend or to stop this trend?
Yeah, there's all kinds of measures that are being done, and really, in response to global sea level rise, it's really tough to counteract that because it's happening everywhere and it's hard to stop the water. So we have a lot of cities that are vulnerable, like New Orleans and Virginia Beach and other coastal cities, and we are really going to have to start retreating from the shoreline or fortifying our shoreline in more detail.
Well, looking at the fortification as far as the shorelines, is there? And we only have about a minute left, so this will be quick. Do we have any practical ways to do that, or is the fact is we need to be much more creative in how we're addressing sea level rise and climate change?
Well, I think in general the best policy is to be migrating out of the areas and kind of decreasing our amount of vulnerability, but in some cases we can't move and we have to fortify in place. So I think it's really going to be a combination of those two. And time will tell. We'll see what happens.
We got about 30 seconds. Well, actually we have about 15 seconds. What do you see over the next 10, 15, 20 years?
I see that sea level is going to rise. We're going to have more impacts from storms, and we're going to be battling coastal erosion and sea level rise.
So it's all going to be there.
It's going to all be there, right on our doorstep.
Well, Randy, thank you for being with us. It's really fantastic the work you're doing. And just going back to look at this, tell us a little bit about this scene right here. And well, I guess we don't have enough time to do that. But thank you for being with us. See how fast this goes. And we're glad you're here.